Then we move on to Richard Trumper from BAE Systems with his roadmap towards the qualification of the BAE joint.
Good afternoon, everybody. So I'm going to talk about the BAE roadmap. It follows a similar path to Cedric's presentation. We're in a very similar industry. Can I have the next slide, please? And I really wanted to start with where we are today from an end user point of view. We very much build our ships out of steel. It's a familiar, mature material. It's very flexible. We have a whole industry geared around that, so it's a known quantity. And we design our ships to survive damage and to be able to be recoverable after damage. Features that are perhaps rather different to the civil marine environment, and we are seeing slow adoption of composites all over the place, but they're relatively small components, and if we move to larger structures, then at the moment we're forced to employ bolted joints, and adding bolts to composites, while it's a known approach, is rather inefficient. You have to do an awful lot of additional strengthening to the joint in order to incorporate bolts. And so for us, Qualify is very much that next significant step forward that allows us to move beyond a bolted joint to something more efficient, more effective. And particularly for us, this is all around the assurance piece. It's no good being able to technically demonstrate that an adhesive bond is fit for purpose if you can't convince a classification society that you've addressed everything. And so when I look into the future, one of the important challenges for us is how do we make our ships lighter? And that's really important for fuel efficiency. And clearly we're heading into a new era of net zero carbon fuels. And a lot of those alternate fuels to diesel are going to be substantially more expensive in the short term. And so fuel efficiency, the ability to save fuel within the same constraints of structure is really attractive. That also means that other emissions such as nitrous oxides will be reduced as well. So that's equally attractive. But it also allows us to trade other opportunities. A warship particularly is there to bring a combat system into theatre, and you have a limited space, you have a limited set of masses that you can cope with on a warship. So a lightweight structure allows us more freedom of manoeuvre. That's really important to these sorts of products in terms of what they actually do. And it opens the door to a philosophy that increases the amount of modularity that we can consider. Our customers are increasingly wanting to be more agile. They want to be able to upgrade their products on a much shorter timescale than they've had to do in the past. And so that interchangeability with a lightweight superstructure and modularity becomes really quite valuable going forwards. Next slide, please. So here are some pictures of our warships in build, and you can see that we are quite used to dealing with large modules. The interesting piece as you start to move towards a superstructure made out of composites is that it in itself potentially is going to be a large structure. So we need to think about not only how do we make that, but how do we transport that? How do we install that? And Qualify is very much thinking of that interface between the composite structure and the steel hull. And certainly for the next generation of warships, I think it's fair to say that we don't expect to move beyond a steel hull, but we do want to make inroads into that superstructure. And as you can see from some of these images, the superstructure is quite large. It's not a small component. And so moving from steel to composite brings a lot of benefits, both in terms of design, flexibility, but also in through life ease of maintenance. So lots of attractions here. I think it's fair to say that Qualify has very much moved the dial from our point of view. And if we move on to the next slide, this is our roadmap. It starts on the left-hand side at the bottom with Qualify. You've heard today a lot of what Qualify has managed to do, and it has done a lot. It has built and validated a whole toolbox of techniques, test measures, understanding quite a diverse range of joints. If you look between the diamond joint configuration and the BAE joint, they're very different, and that's quite deliberate. That's because at the end of the day, we want a set of guidelines that the classification societies can use and can apply, and we can apply from a product point of view that isn't constrained to a single unique joint configuration. It gives us room to flex, to change a few things, to improve going forwards. And I think Qualify has given us both the tool sets in terms of the materials testing, the aging, the structural health tools to say that we now can apply non-destructive measures to not only continuously monitor the joint, and remember the joint on a superstructure is probably the order of 100 meters long, if not longer. So it's a sizable thing to monitor. We've got an understanding of how we might use more localized NDE, how we might use structural health to direct us to some of those areas of concern in the future. And particularly all of that has flowed into the guidelines such that we have for the first time a clear way forward that can be applied to real structures out there in the real world. And so for us, this is very much starting with individual large structural components before we get to superstructures. We're a low risk business in some aspects, so we'll take this piece by piece. But taking Qualify and building on Qualify, applying it, testing how it works as we apply it to real structures, and then moving on into the longer term, thinking about how we move from individual components to either modular or complete superstructures going forwards. And the timing of that is very much aligned with where we think we need to be in terms of our future products. We have ongoing ship build going on at the moment around anti-submarine warfare frigates, and we have a lot of those to build. We build them typically in batches, so the ability to introduce some of this into the next batches becomes really potentially possible. We're not completely there yet, but I think we've come a very, very long way. And then long term, probably in the next 10 years, we'll start to see much bigger structures being considered. And that probably aligns with our longer term air defense destroyer program. We've got time to do that. So for me, I think Qualify has been really useful. It's moved the dial a long way, and we're now at a point where we can start to consider applying this technology for real. And that's quite a big step forward, I would suggest. Yes, there's more to do, and that will be informed by the individual detail that we go through. But I think we have a very, very firm foundation, and I'd like to say thank you to all my colleagues for that. Any questions?
Thank you very much, Richard. There is a question, right, from online. So somebody is saying, thank you, Cedric and Richard, for your presentations of the roadmaps focused on bonding composites and steel. In the future, do you think that adhesive could replace welding in some areas?
So I think the answer to that is yes. I think we're a fair way off that today, because welding is a very mature technology, and it still throws up challenges. I think what you've got to remember is that warships, when damaged, tend to be subject to quite high temperatures. And we have customers that have learnt some very painful lessons in the past. We also know that we can fire protect quite a range of structures. So there's a balance to be struck between the product and what it actually is asked to do and how we build it. I think welding will probably stay a primary joining approach, certainly for steel hulls. But as you start to see potentially more hybrid structures being introduced, then I think adhesive bonding has a real part to play. Again, back to, can we satisfy our customers' defense standards, and can we satisfy the classification societies? And if the answer is yes, then we will exploit those technologies. Cedric, any thoughts from you?
I agree with your comment. I think when welding will probably remain the primary joining technique of metal, because it's very cheap and reliable. But for certain aspects, adhesive bonding can provide benefits for late changes, repair, reduce of stress in the materials. So I think at some locations, yes, adhesive can replace welding. That's
Great, thank you. Thank you both.